Great. All right, so I guess I'll just go ahead and get started. Um, Hello, everyone. My name is Sujay Nair. I'm a junior at Stanford Online High School, and I've done a few presentations at EAS meetings before, whether it be, through like a private Exoplanet group that we formed or, just to the main group. And so today I'm just going to give a really quick talk on, some of the work that your fellow EAS members have done in an exoplanet project, which we plan to actually submit to the American Astronomical Society this coming January. And I think it would be a really great submission. Um, so yeah, so the motivation or the goal of our project is we want to get new exoplanet transit data. And this transit is when, so the exoplanet transit data would consist of, images of an exoplanet coming in front of its host star. And then we can see, when we can detect that when, some of that star's light gets blocked. So we see dimming. Um, so that the goal is to get images from that, and then as a result, update a value called the mid-transit time. Um, so with the data, what we did is we want to plot the relative brightness of an exoplanet's host star against a comparison star. And we use this comparison star to negate effects from the atmosphere. Um, and then additionally, a mid-transit time is when, this planet is in the middle of its transit, where this transit is where it's coming in front of the host star. Um, now, the problem with the mid-transit time is that changes over many periods, which is how long it takes to go around the star, due to the uncertainty in the period of the planet. Um, and so we're basically plotting the target star's light against the comparison star to make a light curve. Now, with our light curves, we can get the expected mid-transit time for the night, and we can compare that to an existing confirmed mid-transit time on the NASA Exoplanet Archive. And we can see the difference between those two values, and, see that change and update it. And that can be really helpful for, this is really great for like large space telescopes that might want to observe this in the future where, time is really valuable. But on the other hand, it's really great because it's a great opportunity to get the community, like the East Bay Astronomical Society, for example, involved in research. Um, all right, so I can talk a little bit about the process and some of the stuff that we've done. So it consists of using, this exoplanet data, and we're using the exoplanet transit interpretation code to reduce and learn about the data. So this group in particular started familiarizing themselves with the code base by running the sample data that comes with the exoplanet transit interpretation code. It's also called exotic. Um, so the sample data is of a known transit of the exoplanet HAPT-32b, and it gave a clear. So this light curve shown on the slide is one that one of the people in the project created. So once everyone could, run through that without any major problems and get this light curve, I put out the data for the planet that we would be analyzing for the main part of the project, which was HATS 4b. Now, this target was imaged by Pat Boyce. He's an astronomer at the SRO observatory, so also somewhat local. The process for this planet, though, would consist of we would want to look at the images, kind of see if there's any faulty images, anything like that, just doing some basic image analysis. We would want to find our comparison stars, and then, of course, we would want to run the data and then go from there. Right now, we're on the running the data section. So, once we get all the light curves and address any issues, we'll start by taking a look at the comparison stars, and we'll check things like their color, their size, their brightness, if they're a variable, a known variable. And we can find all these values in a database like the Gaia data release, 1 or 2, or something like that. And we can learn more about our light curves from doing this image analysis, this comparison star analysis. Once we get a good understanding of the comparison stars, we'll then find the mid-transit phase difference to see how off the existing mid-transit time in the NASA Exoplanet Archive is to what we got. And then lastly, we'll put together our results into a poster format, which would be great for, showing off our light curves and stuff like that, and submit that to the American Astronomical Society. So here, we've got a couple results that we've had so far. they're both light curves of HATS 4b. So the new data, the left one was made by Aishwarya and the right one was made by Jay. And it's really interesting because, so these light curves use different comparison stars, yet, our final light curve was somewhat pretty similar. Just by looking at it, from far away or from just quick glance, these light curves look, exactly the same. And this tells us that they probably chose, assuming this is the correct light curve that we want to see, those calm stars were probably good ones to choose and would be interesting to further analyze. Later, we're going to use those mid-transit values corresponding to each of those light curves to see the differences compared to the NASA Exoplanet archive, which is, one of the more important values that we want to see. So what are our next steps? Well, we want to definitely finish the reduction and get a few more light curves of the data. Once that's done, we'll check all of our used comparison stars to learn a little bit more about the light curves and the data itself. And even just by learning about the data itself, that can be useful not just for the exoplanets or the work that we're going to be submitting, but that could also be useful for the person who took the images of the data, for example. Next, we'll find those mid-transit differences for each light curve. And then with that, for each of many light curves, we can make a general claim about the mid-transit for the planet in its entirety, which we can then put on a poster or paper or some submission to the American Astronomical Society. So I look forward to sharing more progress on this project as it progresses. Ideally, I can give like a progress update every major step of the way. So maybe once we get the comparison stars figured out, we find something interesting there, or then once we get like a general claim about the planet, or if anything really cool comes up on the way, because there's still so much more opportunity, then I'll definitely be able to give an update like that. So yep, that's it. Thanks everyone.
Great, thank you. That's really great. I thought it was pretty amazing how similar those light curves were between the two participants there. It was actually pretty dramatic. So, oops, one other person jumping in. I have to apologize that she hope she didn't miss too much. She would have missed all of it. Linda, sorry you missed the entire presentation, but it'll be recorded and put up on our YouTube channel, and I'll send out an announcement when that's ready. I'll have that up sometime tomorrow, most likely, so you can replay this. Do we have any questions? Any questions? Anybody? You have to unmute yourself. Anyone? Okay.
I've got a question.
All right.
What is the size of that planet what do you surmise the size of that planet is, and what is its year?
That's a good question. That's actually really interesting, especially for the analysis we're going to be doing. I'm not exactly sure what its year is. I know, at least based on when it's been updated, the last time that its values were checked by the NASA Exoplanet Archive was like I'd say between 5 and 6 years ago. Its size, I'm pretty sure this is a hot Jupiter. So a hot Jupiter planet. It's decently far away. So it's a somewhat dim target in the images. I'm not sure the exact value, though the name of it is HATS 4b, in case you wanted to learn more about the characteristics of it. Yeah.
Okay. I have a follow-up question to that. When the planet comes in at the edges of the star, is some of the light reflecting off the planet getting to us, or is it just all, you know what I mean? Does that alter the
Right.
subtraction of the?
Yeah. I think I know what you mean. As if like sometimes when it's on like the very edges of the planet, the reflection can almost increase the brightness a little bit.
Yeah.
In this case, it's far enough away that and the data is rough enough that we can't particularly detect that in our images. The greatest difference that we can see is the dip in brightness, and there probably is like a very slight increase in brightness.
It gets lost in the noise.
Yeah, I feel like it might get lost in the noise.
Okay. Thank you. You're very impressive, by the way.
Oh, thank you.
Wow, is that Celeste Burrows I see? Hi, Celeste. Nice to see you. And Don, turn around very slowly. You got a real dangerous creature behind you.
I don't dare.
All right, any other questions? Anyone? Okay. Well, look, we'll be keeping everybody up to date. I will announce further updates. My apologies again to everyone who tried to tune in last week and found nothing but a blank screen or a dialog box that didn't go away. That was entirely my technical fault. And I will not, or I'll try not to let that happen again. So Sujay, thank you much, and I will be posting to Night Sky Network and to the EAS list when this is available on our YouTube channel. You should also know that our speaker from last week is now available on the YouTube channel, and the website has the link to it. So if you missed our speaker last week, you can watch the whole thing at your leisure. That's it. All right. Good night, everyone.
Thanks. Bye, everyone.
Good night.